So what I get asked a lot is, hey, Miss Cole, how do I know if I should do Pythagorean theorem or if I should do sine, cosine, tangent? That's a really, really good question. If you have an angle, you should do sine, cosine, tangent. If you don't have an angle, like all you have are sides, you would do Pythagorean theorem. Are we together? Okay. So since I don't have an angle for this one, we're going to do Pythagorean theorem. It would be x squared plus 8 squared equals 12 squared. So this would be 64. This would be 144. Am I like, is this what you got? We're all together here? Okay. I got to go through them faster if you've already given them a shot because we're sort of just checking. Subtract over the 64. What did you get there? 80. And then your last step is to square root. So now you have to split 80. So you remember, you have a calculator. You would want to try 80 divided by 25, 80 divided by 49, like some things that are perfect squares until you get one that comes out. Good. 16 times 5. And the whole purpose of that is like you can actually do square root of 16. So it would be 4 square root of 5. How did that one go? Like thumbs up, thumbs down? Basically, all right. Okay. This one is the only one on here I would not require work for because it's one of those locker combination ones. And like listening to you, some of you remembered it. 7, 24, 25. That is the only one that I wouldn't require work for. What's some of the other triples that we did? What was the little one that I was like, if nothing else, give me this one? 3, 4, 5. Nice try. 3, 4, 5. We had 7, 24, 25. Oh, whoops. Do you remember any other ones? 5, 12, 13, and 8, 15, 17. A lot of times if you see 2 of the numbers, it'll kind of jog your memory what the other one is. But anyway, I digress. Now, this has an angle labeled, and this one has an angle labeled as x. So these two, we need sine, cosine, tangent. This is your point of view. It's like you are here, the one that's labeled. So 9 is the opposite. X is the adjacent. Is that sine, cosine, or tangent that has opposite and adjacent? Tangent. Well, if you don't know them yet, that's okay. You'll need to know them by the time I hand you a quiz or test, all right? So it would be tangent of 53 degrees equals 9 over x. That's what I need to see written on the paper. Okay? Now, how would you type that? Good. 9 divided by tangent 53. And you need to be in degree mode or it's not going to work. 3 decimal points, I got 6.781. Is there confirmation? Okay. I like confirmation from you guys on the button pushing because guess what? I'm a human and I make mistakes too. And if you button push one thing wrong, it's going to be wrong. So I like to make sure like we all got the same thing. All right, here's our point of view. It's like we are here. This is the one that's labeled. I don't have the opposite, but what is 14? 14 is hypotenuse, 10 is adjacent. So if you have adjacent and hypotenuse, sine, cosine, or tangent? It is cosine, good. Cosine x equals 10 over 14, and then you type it in. Like it's the setup and then you type it. It's the setup and then you type it. So I need to see those 2 things on the paper, like how you set it up and then your answer. Now, how do we type that one in since what we want is the angle? Second, oh, and you even use good vocabulary, inverse. Second cosine, which will give you a little -1 in there. That's the inverse. 10 over 14. Boom, that's your answer. So 44, or did anyone else get 44.415? Thank you. And I will not mark it wrong at all. Like if you get the right answer, fantastic. But I'd like it if you put a degree symbol if it's an angle, only because we're going to do a lot with angles and sides in this unit and from now on. And the degree symbol helps you remember that's an angle, not a side. Okay, so I'm just throwing that out there. That's what we did last time. If you weren't here, that's what you missed. Okay, now we're going to go further with that. So looking at this one, do you see how it's one of your locker combinations, the 8, 15, 17? Don't look at these for right now. I'm going to talk about that, but let's just do sine, cosine, tangent. Here's your point of view. That little Easter egg looking thing, does anyone know what Greek letter that is? Oh, theta, good. This is your point of view. You are here. It's theta. What did you say? Okay. Well, it's theta. We use theta for angles usually. So if you are here, 15 is the what? Good. Opposite. What is 17? Hypotenuse. 8 is adjacent. And again, don't look at these for right now. I'm going to talk about them in just a second. So sine would be opposite over hypotenuse. That would be 15 over 17. If you're like, that's it? Yep. That's it. What would cosine be? Good. So that would be 8 over 17. If you're like, that's it? Yep. And then tangent is good. So 15 over 8. Now, these three are 3 other trig functions. If you're like, gosh, how many trig functions are there? That's it. There's 6 total. Okay, so there won't be any more than this. And I just really wish, and I get why geometry teachers don't do this. It's not in the curriculum, but I just wish they would take like 30 seconds and go, oh, by the way, there's these other 3. And all you do is reciprocate these. So this one is 17 over 15. And I'm going to tell you what they mean, okay? This one is 17 over 8, and this one is 8 over 15. If you're like, that's it? Yep. Okay, but humor me, because we're going to pause for a second and take like a 5-minute conversation about words. We're going to talk about vocabulary really quick, okay? And I feel strongly about this, which is why I'm going to like preach at you for a second. Humor me, okay? And I was talking about this a little bit last time. Your words and your thoughts are connected. And then that is in turn connected to your actions. And this is applicable in every aspect of life, okay? If you think it correctly, you're going to say it correctly, you're going to do the problem correctly. I'm going to correct you if you say these words wrong, because I feel strongly that it helps you actually understand the material. SIN is an abbreviation for the word sign. It is actually spelled SINE. That's the word sign. Write it down. That's how it's spelled. When you spell the word sign, like SIN is an abbreviation. It's not the actual word. Cosine is sine with a co in front of it. They're co-functions. I'm setting us up for something that's going to be important later on this year. I'm doing like the groundwork for this. All right. So it's sine with a co in front of it. It is cosine. That's how the word's actually spelled. COS is an abbreviation. Tangent is not difficult to spell, so I hope that one's okay. Now, these other 3, I'm going to start with this one. COT is cotangent. It's like how sine and cosine are co-functions. Tangent and cotangent are co-functions. It's tangent with a co in front of it. And I saw a lot of you start to write it before even I did, because you listened to me and you understood. So nice job. Cotangent. If you call it cot, I'm going to correct you because you don't understand that it's a co-function to cotangent. SEC is secant. And then any guesses for what CSC is an abbreviation? Good. Okay, see how you understood it when we went through the words? Say them correctly, you will think them correctly, and then you will do the problem correctly. Now, the next thing I'm going to talk about real quick, and if you don't want to write this part down, that's fine. Sine and cosecant. Do you see how we just flipped them? They are what is called a reciprocal. A reciprocal means that you have flipped it over. So, for example, 2/3 and 3/2. You've flipped it. So if you say these are reciprocals, that's good. Here's what I get a lot of times is people call them opposites. And if you say that, I'm going to correct you because it means something different. Here's what an opposite is. Give me any number, like a little number. Okay, 6. The opposite of 6 is -6. When you opposite something, you negate it. So if you say these are opposites, I'm going to correct you and be like, no, they're reciprocals because it is different. And then the last word I'm going to talk about, like how much more of this is she going to go through? Inverse means you have switched x and y. These are functions that undo each other. So for example, an x squared and a square root. Do you see how those are inverse? I know some of you have glazed over. It's important. That's why I'm talking about it. Do you remember e to the x and ln of x, how they undo each other? Those are inverse functions. The inverse of sine is sine inverse. Sine with little negative, coming with me on this? Sine with little -1. Inverse sine is inverse sine. Cosecant is the reciprocal. These words are important. That's why I went through it. I will correct you if you say them wrong because they're different. Okay? I know, really. Message delivered, Miss Cole. Now leave us alone. We're going to try this one. Now we have a side that is missing. So I'm going to pause the recording real quick. Let's call that A. I want you to do Pythagorean theorem and find A because it's missing and I can't answer any of this without A. So call that A or call it X or whatever you want and go and find that missing side. All right, let's see how this went. You're going to do A squared plus 4 squared equals 14 squared. And remember, you get a calculator. You don't have to know 14 squared off the top of your head. What'd you get when you typed that in? 196, good. Subtract the 16, we get 180. Square root, and I heard some people say 36 worked. What was the other number? 5, good. And so we get 6 square root of 5. I'm just going to write that over here so that I have it in the triangle. 6 square root of 5. Now we're going to do the exact same thing we did with this one. It's just that because there's a square root in there, there's going to be a little bit of simplifying. These were all nice whole numbers. This one's going to involve a little bit of simplifying, but it's the exact same like idea. Good.
If we get a number that would be like
Square root it like perfectly?
no, like, well, like, for example, I did like this time and it got 4 and 14. Like that.
Oh, no. Okay, that's a really good question. Can I address this for everybody? You can't do sine, cosine, or tangent because you don't know what this angle is. Like, that's a missing piece of information. Do you get what I'm saying? I guess you could do, did you do cosine and like find the angle? See, we don't actually need that angle though. What we needed was the other side. So you want to do Pythagorean theorem. You can find that angle if you want, but it's not necessary to the problem. So you're doing like, yeah, like you're doing unnecessary. You're not wrong in any way, but it's like.
But the only things that were available were cosines.
Well, it's like question 1. Like we had these 2 sides and we wanted the other side. We don't need any of these angles. So you would not want to do sine, cosine, or tangent. You would just do Pythagorean theorem. So you can get that answer, but it's not part of the question. Okay, here's our point of view. Let's label this 6 square root of 5 is what? Opposite. 14 is hypotenuse. 4 is adjacent. Okay, we're going to do just these 3 first. Don't look at these. So sine would be what over what? Good. So it would be 6 square root of 5 over 14. I'm going to go through and just write them all out. A lot of them will need simplified, but let's just write them first, okay? Cosine would be what over what? 4 over 14. And then tangent would be 6 square root of 5 over 4. For these 3, you're just going to reciprocate them. Just flip them over. So this would be 14 over 6 square root of 5. And yes, like all of these are going to need simplified, but just write the answers first. Secant would be 14 over 4. Tangent would be 4 over 6 square root of 5. Let's do the ones that don't have the roots in them first, because those will be easier. Let's do cosine and secant. How is this going to reduce? You just have to reduce the fraction. It'd be 2/7. And then that one's 7 over 2.
That's what I'm asking about those.
Yeah, if it reduces, then you need to do it.
I wasn't actually finding the angle. I was trying to.
Okay, then you were just ahead of me. Okay. So here, 6 and 14, again, they're going to reduce. So how would the fraction reduce? You can't touch the 5, that's in the root, but how would this reduce? Yeah, it'd be 3/7, and you just kind of leave the square root of 5 there. So this one would be 7 over 3 square root of 5. The problem is that one's not finished, unfortunately. And I don't really like this rule, but it's the rule and we have to do it. And you'll all be okay. You're not allowed to have a root in the denominator. So how did we handle that? Yeah, multiply it to the top, right? Like multiply by square root of 5. So this would give you 7 square root of 5. Now, normally it would be over 5. but there's a 3 there. So, oh, good. 5 times 3 is 15. Sometimes that's a struggle to get everybody there, but that sounded like that when 5 times 3 is 15. We together? Okay. Now let's do these ones. 6/4 would reduce to 3/2. So 3 square root of 5/2. And then this one would be 2/3 square root of 5. Unfortunately, though, you need to rationalize that one. So you would times it to the top, like times by square root of 5. So 2 square root of 5, that would be over 5, but there's a 3 there. So 5 times 3 is 15. So if there's a root in there, you just have to reduce them. So whenever you're doing these story problems, there's 3 parts to it. And I make them worth 3 points. The picture, and the picture is going to be a triangle. Okay. So the picture, setting it up. So I want to see something with a sine, cosine, or tangent in it, and then the answer. Okay. So there's really like 3 parts to it. Real quick, and in this space here, we're just going to do like 2 little pieces of vocabulary. The first one is angle of elevation. Does that ring a bell? You actually do this in geometry. I realized that was a couple of years ago, but like, it's the angle when you're looking up. So it's the angle with the ground. It's the angle with the ground. So if you're looking up, it's the angle you make with the ground because you're looking up. You're on the ground. So you're looking up. The other one, I don't like what it's called, but does anyone remember what it's called? It's called the angle of depression. It's the opposite. It means you're looking down. So you're not on the ground. You're like on the top of a building or something like that. So you're looking down. So it's the angle that's made with the sky. But here's the thing. Since the sky and the ground are parallel, and I know that the earth is round, but like in general, parallel. Can we go with that? Here's the sky. Here's the ground. This would be an angle of elevation. This would be an angle of depression. They're actually congruent. They're the same. Does anyone remember what these angles are called from geometry? If not, we'll play hangman. And then you're all going to be like, oh, yeah. Well, these 2 are parallel, but I'm asking what these 2 angles are called. Oh, no. Are we going to guess a letter? What's that? N?
No. What?
No, there are more vowels. What's that? Alternate. Interior. Anyway, for what it's worth, that's what they're called, and they're the same thing. So an angle of elevation and an angle of depression, one's looking up, one's looking down, but because the sky and the ground are in theory parallel, they're actually the same angle. So you can't mess it up. Okay. So number 1, we're going to draw a right triangle. A ship is offshore from a vertical cliff. Here's the water. You got to have an imagination. Do you all have an imagination? We had a childhood. Okay. So your water is down here. If you want to draw like anything, like the boat is offshore, you don't have to draw, like all I need is a triangle, but if you want to be creative, you can. The cliff is 100 feet in height. So here's our 100 feet. This is the vertical cliff. We take a sighting to the top of the cliff. The angle of elevation is 25 degrees. Your 25 degrees goes right here. How far? This is your question mark. This is what we're going to call X. Okay. How far offshore is the ship? Where does the X go? The bottom. Oh, and good. It's the adjacent. So that's step 1. Draw a triangle and label it. Get a point for that. Now we're going to set it up sine, cosine, or tangent. You can still label if you want, but I want you to start trying to like remove those training wheels, okay? This is your point of view. This is opposite, this is adjacent. So do you want sine, cosine, or tangent? Okay, tangent, 25. And here's the end of the story, right? And I said this when we started over with trig. The rest of the year is triangles. Your world is very small. If you forget, it is sine, cosine, or tangent. If you forget, you have a 1 in 3 chance of flat out guessing. Do you get what I'm saying? There is very little room for error in these problems because you have almost no choices, right? Tangent 25 equals 100 over x. That's step 2 is set it up. And then how do you type that? Perfect. 100 divided by tangent 25. Now, does the answer kind of make sense? Well, the cliff was 100 feet high, so getting something in the hundreds makes sense. 214.450 feet. And you do need the units because it's a story problem, but don't make them up. Feet is in the problem. Or did anyone get the same thing as me? Did I type that? Okay, I like to make sure you got the same thing because if I button push something wrong, it's gonna be wrong. All right, draw a right triangle. All right, so for this one, a 22-foot ladder is leaning against the building. Where does the 22 go? You have to imagine the ladder leaning against the building. It's the hypotenuse. Good. The ladder leans against the building. It makes a 70-degree angle with the ground. So here's our 70 degrees. How far? This is your question mark. This is X. How far up the building does the ladder touch? Where does X go? Opposite. And you guys are even using words like opposite, adjacent, and hypotenuse, which is awesome. That's step 1. Step 2, do you want sine, cosine, or tangent? It's going to be sine. Opposite over hypotenuse. So sine 70 equals X over 22. Now, how would you type that? That's step 3 is type it in. How would you type that one? Good. This gets multiplied over. So it's 22 times sine 70. You'll get used to it the more you do. And again, like I was saying, if you honestly, if you get stuck, make them all tangent or something. Do you know what I mean? On your test, like if you are absolutely like, I just can't remember, just do them all this. Like, yeah, you'll lose a few points, but like you'll get through it. You only have 3 choices. Okay. Draw a right triangle.
I did it.
Do you see how doing a bunch of problems helps you get it? Like you just have to do a lot of practice. All right, a radio transmission tower is 200 feet tall. Shh. How long should a guy wire be? Did you ever see like a plant that's growing and they tie like a thing to it to the ground, or like a radio tower and they have a thing tying it to the ground? It's to steady it in the wind or whatever. How long should the wire be? So the wire is the part like attaching to it. So this is what we're looking for. Now, here's the tricky part on this one. The tower is 200 feet tall, but we're attaching the wire 10 feet from the top. So this needs to be 190. The tower's 200 feet tall, but like it's not getting attached right at the top. It's 10 feet from the top. So 190. I need an angle though. So it's 21 and with the ground. So 21 goes here. That's step 1. Step 2, sine, cosine, or tangent. I'm hearing all 3. Opposite and hypotenuse is sine. So sine 21 equals 190 over x. Step 3 is type it in. Yep. Yeah, these aren't bad. They go quick too. The quiz is like this, which we're not doing anytime soon. We're only day 2 into this unit, so calm down. All right, draw a right triangle. It's fine. I'm not grading your art skills. All right, let's read number 10. You have to be able to read them and interpret what's going on. Now, you're not on the ground on this one. You are standing at the top of a building looking down at your friend on the ground. So you're up here, your friend's down here. It says the angle of depression is 56. Watch me draw this. This is the sky, which is invisible, so I'm dotting it in. This would be your 56 degrees. But again, because in theory, the ground and sky are parallel, that 56 is the same as this angle right here, which is 56. So what I'm saying is just always put it down at the bottom. Does that make sense? Yeah, just always put it right there. Like if you draw them the same every time, because they're equal, they're congruent. It's because we're not on the ground in this problem. We're looking down. So, all right, now I need more information. Shh. Your friend is standing 40 meters from the building. So where does 40 go? 40 goes along the bottom. And then X, wait, what is X? How tall is the building? So X is there. So you actually don't need this part. Like you don't need that.
Wait, was this always?
Yep. I just work here. All right, sine, cosine, or tangent? Tangent, good. Tangent 56 equals X over 40. And then step 3 is type it in. How would you type that one? Good. 40 tangent 56. So 59.302. And then is it feet again? Oh, meters. That's why reading is important. Number 11, draw a triangle. Yeah, where is he?
Hey, dude, it's something about his sister, like pink guy.
Oh, okay. All right. We're becoming unfocused. Oh no, that's to do a few more. Okay. No, we're not. We're disagreeing. All right. 25-foot tall tree. So where does the 25? You have to have an imagination. Yeah. Yeah, on the left, or it's going to be opposite of the angle. Cast a shadow 38 feet in length. So where does the 38 go? On the bottom. Shadows go along the ground. What is the angle of elevation? Ooh, so X is your angle this time. Indeed. What did you guys say? The one indubitably or something? So sine, cosine, or tangent? Tangent, good. Of X is 25 over 38. So step 1, draw a triangle. Step 2, set it up. Step 3, type it in the calculator. Go ahead. Inverse tangent. So how do you do inverse tangent? Good. Second tangent. Oh, good. Awesome. Second tangent, 25 over 38. Now your units for this one are not feet or meters. It's degrees. So that little symbol right there is your units. I get some people that like to write out degrees, D-E-G-R-E-E-S, because it makes them feel like they actually put a unit there, but I'm fine with just putting the little degree symbol. That's good. We'll skip number 12 because it seems like you guys are getting the hang of this and it's like just more of the same. These last few are a little bit more complicated because I believe in you and I think you can do it, okay? So let's look at number 13. From a window 30 feet above the street. Okay, so let's just draw a little line and call that 30. So like you're in a building that's like your floor is 30 feet up. The angle of elevation to the top of a nearby building is 53. So look, this is the shorter building is 30. We have a taller building over here. Well, I didn't get there yet. You guys have to stay focused. I'm gonna connect them and create this right triangle. So it's a right triangle that's just 30 feet up in the air. It's a right triangle on stilts. Okay, it's like an acrobat triangle. Now, what was the angle that's gonna go in there? 50, right? So 50 goes right there. Now the angle of depression to the bottom of the building, so we're gonna connect, you end up with two triangles here. It looks like a little paper airplane. To the bottom of the building is 20. Now, in this case, because I have this, like, basically the sky sort of drawn in here, the 20 is gonna be right here. Because you are at the top of the 30 feet building looking down. The 20 could also go right here, but I'm not connecting these. That would, like, I don't need that part of the problem. All right, what are we looking for? What's our question? How tall is this whole building? Well, look, what's this part? What's just this part? That part's 30. Because if this is 30, that's 30. So really, I just need that piece. And then I can add them together and get the total height of the building. Here's the thing, you can't jump straight there. I can't jump straight to that. I need to know how far apart they are from each other first. Okay, and I'm going to teach you some intricate things in the calculator that you're going to need to listen to. What do you want to call this distance? I usually call what I'm looking for X, like X is the goal, but I need a name for this. Can we call that Y? Does that work for everybody? So I'm gonna call that Y. You can call them A and B. You can call them Q and R. You can call them whatever you want. It's like the missing things, okay? So let's see, how could we find Y? Why don't we look at the bottom triangle, try to just focus on this one. Sine, cosine, or tangent. I need to set up some kind of a problem. Try looking just at the bottom triangle. Oh, it will be tangent of 20, good, equals what over what? 30 over y. So I just looked at the bottom triangle. Tangent of 20 equals 30 over y. Let's type that in, and you're going to have to all stick with me here. Okay, how would you type that? Good. 30 divided by tangent 20. Now, here's the thing. You have to capture that number so we can do a copy paste. Like we have to do the copy part of a copy paste. Are you coming with me here? So I have to reuse that number again. Watch me do it. Then you guys can repeat the process. Just watch, okay? It's not hard, but you have to listen to what buttons to press. Do you see this button right here that says stow? That's store. Don't do it yet. Just watch me. I'm going to hit store. Do you see how it put a little arrow? Now you can store it as any letter of the alphabet you want. Do you see these little green letters here? A, B, C, D. You have the whole alphabet. I always just store everything as A. And the reason why is it's the first letter of the alphabet, and the A is actually right next to the alpha button, so it's just convenient. But you can store it as whatever letter you want, okay? But you hit store, and I'm going to do alpha A. It puts the A on there, and then I'm going to hit enter. Store alpha A, enter. Store alpha A, enter. Store alpha A, enter. I just say it over and over again. Store alpha A, enter. And what it has done is it has captured that as A. Store alpha A, enter. I'm just going to hold on a second. Did you all store it? Store alpha A, enter. Now we're going to go back to the problem. We've stored that. Oh, let me write it on the paper too. What was it? 80 something? 82.424. Okay, but we captured it. So now we're going to look at the top triangle. X is our goal here. So just looking at this top triangle, what is a problem we could set up to try and find X? Oh, it's tangent again. Tangent of 50 equals X over Y. Now, whatever you write for Y is honestly fine for me. You can just write the letter Y. You can write this number. You could just write 82. You could write A. Like any of that's fine because the calculator's gonna do it for us. I'm just gonna write the number. But again, like up to you. So what would you do to get X by itself? Like what would you do there? You would multiply this over. Don't type 82.424. What you want to type is alpha A, and it will paste that number in there for you. It's a copy paste. So alpha A tangent 50. Okay. And just real quick, that's actually not the final answer because it was how tall is the building? What do you have to do to that? So hit plus 30, and that's the total height of the whole building. If you were like, that was a lot, that took a little longer because I was explaining everything. When we try another one, it's not going to take as long. Let's try number 15. We'll skip 14. We'll just do 15 and 16. We'll end with that. I'll fill in the other ones so they'll be on Schoology so that you can check them. So they're trying to read 15 for me. So what are we standing in front of a mirror for this one? Okay, so you are standing in front of a mirror. So like here's your eyeball. Okay, don't make fun. I can't do. Yeah, I'm gonna skip 14 because I want you to have time at the end, and these are all kind of similar, these last ones. And then here's your mirror. Kind words only.
Yeah. What?
I don't know. All right, we're 150 centimeters away. So if you connect to the mirror, you are 150 centimeters away. So here's where you're looking. You're like, you've all stood in front of a mirror. Do you know what I'm talking about? Here's the mirror. Here's you. You're looking at it. Or you imagine it. You have to have an imagination. Okay. Angle of depression. That's looking down to the bottom of the mirror. What's that angle going to be? 12. 12 degrees goes right there. I'm sorry, it got really small, but 12 degrees is that angle. Looking up to the top, so if you connect to the top, what is that angle? 11. So 11 degrees is that. So this one's 12, that one's 11. We're 150 centimeters away. What is the vertical measurement of the mirror? It's again going to be a two-part problem. We're going to do the one on the bottom. I'm going to call that X. We're going to do the one on the top. I'm going to call that Y. And then what would you do with the two numbers? Add them together. That'll give you the total. So let's do just the one on the bottom. What problem could we set up sine, cosine, or tangent to do this one? Tangent of 12 equals X over 150. Shouldn't put this on the recording, but I'm going to say it anyway. If you aren't sure, pick tangent. Because having the hypotenuse is not very likely. So like, if you're not sure, pick tangent. All right, how would we type that in? Good, 150 tangent 12. Did you get 31 and some change? Okay, so write it on your paper, but you have to capture that. We have to store it because we're not done with the whole problem and we need to do a copy paste. Store alpha A, enter, store alpha A, enter, store alpha A, enter. What I usually get asked is, how do I clear out A? You don't. You just keep restoring over it again and again. It will never be blank or empty. I'm really sorry if you're very type A and that bothers you, but that's just like, if you want to clear the memory of your calculator, you can do that. But you just keep copying over again and again. All right, so store alpha A, enter. Store alpha A, enter. All right, now we're going to do the top of the top triangle. How would we set up a problem for that? Tangent 11. It would be Y over 150. And we're going to type that one in. So it would be 150 tangent 11. Bless you. No, if you have it stored, you can clear it. It's fine. If you stored the first answer, it's not gone. I got 29.157. Okay, that's not the final answer though. You have to do plus what? Alpha A. You have to take that and add the first answer. So I got 61.040 and then centimeters. So when there's two triangles, you do two problems, and then usually you have to add or subtract them together. We're just gonna try one more. Adorning the top of the Board of Trade building in Chicago is a statue of Ceres, the Roman goddess of wheat. This is actually true, and you can look it up. It's a cool statue. All right. From street level, there's two observations taken. All right, draw yourself a big triangle. And we're gonna have to have an imagination here because I cannot draw a statue of a Roman goddess of wheat. So you're gonna have to like imagine it. I'll try with a stick figure here.
I think it's this.
Well, here, I'll give it a shot. Here's the building. And here's the statue of the lady on top of it. No. So there's a building and then the statue is on top of the building. Are we imagining this? Okay. So from street level, so from down here, two observations are taken 400 feet from the building. Where does the 400 go? It goes along the bottom. You're like 400 feet away. The elevation to the base of the statue. So that's to her feet. That angle is 55.1. So 55.1 goes right there. So to her feet. There's two triangles, but to see how one of them's inside of the other. All right. The angle to the very top, so this whole thing is a little bit more. It would be 56.5. That should make sense, guys. If I look at her feet, you see how it's one angle, and then if I look up, it's a bigger angle. Like, okay. So two problems are going to be set up, and they're both going to be which sine, cosine, or tangent? Both going to be tangent. All right, so let's set up the first one. Tangent of 55.1. And we need some variables in here. We're looking just at the smaller triangle. We're looking just at this one. So let's call this, yeah, can we call it X? Does that work for it? I usually just go with X and Y. So X over 400. I knew what you meant. X over 400. So actually that's going to give us the height of the building. When we find X, that's the height of the building. All right, so go ahead and type that in. It'll be 400 tangent 55.1. You should get a large number. Hurry, capture it before it gets away. Hurry, capture it. Quick, get it. I don't know. I try to be silly so everyone remembers to store it. How do you store it? Store alpha A, enter, or whatever letter of the alphabet you want to use, but I just always go with A. All right, we captured that. I don't need that anymore. Now we're going to do the other one. Tangent of 56.5. Now we're doing the whole triangle. It's the whole big thing. So I'm going to call this Y. Y is going to be like all of it, like the building and the statue together. Because we're looking up to the top of her head. Do you get what I'm saying there? Like it's the whole thing. So this would be Y over 400. Go ahead and type that in. Tangent 56.5. Yep, good. Now, would you add or subtract those numbers? Oh, good. Okay. Usually I have to fight through that one, but you guys, why is it subtract? You just want the statue, right? You have the whole thing, subtract out the building. That's going to give you the statue. So you're going to take what you have right here and do minus alpha A. So how tall is the statue? 7. And was this in feet?